Boarding. Um, so yeah, where would you like to start?
Okay, I just want, sorry about that. I just want to let you guys know this is just a safety review meeting. This is not going to be scored at all. This will not go to any points to your final score at competition.
Okay, sounds good.
And with that, I'll let you guys introduce your team, a quick introduction, and we'll start off with the nose cone after that.
All right, for sure. So I have myself. My name is Zach Loudon. I'm the project lead for this project.
I'm Taylor. I'm the payload lead. Spencer. I'm one of the recovery leads.
I'm Jaden. I am the mission operations lead.
Hi, I'm Matthew. I'm the other recovery lead.
I'm Sean. I'm the airframe lead.
I'm Ian. I'm the avionics lead.
And I'm AJ, one of the Boston co-leads.
And that's everyone. Thanks for joining as
Awesome.
well, Gary.
Oh, you're welcome.
All right, you said to start at the nose cone.
Yep. So your nose cone, is it fiberglass, carbon fiber, POTS, SRAD
Um,
made?
SRAD 3 printed. Open.
yeah, SRAD 3 printed Altum is our nose cone. I get 98.
Oh, yes, yes, yes. 3D printed. Hold on. And is the shoulder length of the nose cone half a caliber or greater?
Yeah, I think.
I'm assuming you have a 6-inch
Yep.
airframe,
Yes.
Yes.
or what's your airframe diameter?
6 inches.
6 inches, yeah.
Can you compare?
Can you hear us still?
Uh, very lightly, you said 6 inches?
Yeah, we said 6 inches.
Okay, so your shoulder length should be a minimum of 3 inches. Um, do you plan to deploy your nose cone
We're not
or separate your nose cone?
we're not deploying our nose cone, no.
Okay, when you go to the convention center, we will do another in-person safety review. I will most likely not be a part of that review. There'll be other safety reviewers, and everyone else has different safety concerns. They may not like the smaller than 3-inch shoulder for your nose cone, but since it's not being separated from the um rest of the body tubes, just make sure you have multiple mechanical fasteners to keep it that from unscrewing.
Okay.
Um, at the moment, how many fasteners are you using on the nose cone?
We have 6 fasteners.
6, and what size screws?
It's 8 by 32.
32s.
Is that the
You
speed?
said 432s?
832s.
832, okay. And not being deployed. Anything going to be contained inside the nose cone? Looks like possibly a camera.
The avionics bay is in the nose cone.
Okay. And how will that be secured in the nose cone?
Bulkhead, the same place where right along here. There's just gonna be a bulkhead there that's connecting the nose cone and the tubing as well as the avionics bay connects to that too.
Okay, and then can I see the avionics sled or bay that will be in the nose cone?
We don't fully have that finished yet, the avionics bay itself.
We have still need to 3D print it, but we're hoping it will end up looking something similar to this.
Okay.
So we're hoping to have this.
Previous years.
Yeah, this is the previous years, but we're hoping to have it basically slide in just like that.
Pretty much exactly the same, just different dimensions on it.
And then it would have a bulkhead on the bottom that would connect.
Okay. And pretty much it will just sit on top of the screws or will be screwed in with the screws of the nose cone?
To which piece?
It'll be screwed into the face of the bulkhead, not on the radial edge.
Okay. And then what batteries will be powering your avionics bay?
These batteries here. So we have our AIM Extra being powered by these two batteries, the 7.4 volt for the e-matches, and then this 7.4 for the actual computer. This 7.4 volt will be powering our Blue Raven, and then this 3.7 volt will be powering our Featherweight. And then we also have this big old 7.2 volt, which will be powering our camera system.
Okay. And I saw that you guys have the lithium ion in the cylindrical cell, which is great to see. And then the lipo, I'm assuming, is re suggested by the manufacturer and provided by them as well to power the featherweight, correct?
Yeah, this came with the Featherweight.
Okay, which is also good. If it wasn't required or if it wasn't provided, we wouldn't be able to fly that.
Yep.
But since Featherweight gave it to you, that's the recommended battery for that product. And let's go to the body tubes now. Are these also SRAD tubes
No, these are cots.
or COT tubes? Okay. What's the material composition of the tube?
So the first one is like a phenolic fiberglass that's like phenolic on the inside and then wrapped in fiberglass. And then the other remaining tubes are carbon fiber, both the couplers and the outer tubing.
Okay.
Bulkheads, most of the bulkheads are made from G10 fiberglass, except for the thrust transfer bulkhead at the very back, which is aluminum 6061.
Okay. And how thick is the bulkheads?
The bulkheads are 1/2 inch.
Okay. And the thickness of the body tubes?
I'd have to double check. I can't remember exactly what they were.
Okay.
We can grab our calipers and measure that if you want.
Yes, please. And then what will be contained inside of each body tube?
So at the top here, this will be containing our payload bay. 106 inches on
So it's 0.06 inches for the body tubing.
Okay, awesome. So the phenolic covered in fiberglass will be the payload bay?
Yes.
Correct.
So, payload and main
Okay.
bay. So at the top of the tubing, we'll be having our payload bay. On the bottom is the main bay. And that'll be
Okay, and will the payload be ejected in flight?
no.
Okay. Attached. Um, will there be any electronics on the payload as well?
Yes.
There will be.
Um, well, just you guys are doing the
Blood vessel has.
blood vein
Yep.
payload, correct?
Yeah, that's correct.
Okay. So no alternative GPSs, that's fine with me. What batteries will be in the payload?
Do you have the batteries, Taylor?
I do. Phone charger batteries? I forget the specs of them. I could send that information to you after.
Okay. And then I see that looks like a 3U CubeSat with that's made out of aluminum.
Yes.
Okay.
For a, I don't know.
And then make sure on your payload you include your team number and frequency as well which is also stated in the D tag 9.5.
Okay.
You could write it on or make a quick sticker with the team number and the frequency number
Okay.
if you are sending signals out of it.
For now.
Okay, so let's go back to how will the payload be mounted inside the tube?
2 bulkheads.
So we have these 2 bulkheads, which will be screwed into the tubing.
Okay. And how many fasteners on each bulkhead will be fastening it into the tube?
The payload or the bulkhead?
There's 6 of them.
6 on each side, okay, for a total of 12. And are they also 8 30-seconds?
Yeah.
Okay. And then so it's going to be the nose cone, then the payload, correct? You
Yeah.
said? Then the main
Yes.
parachute?
Nose
And
cone.
then how many grams of black powder or CO2 do you guys plan to use to separate the main?
In the main, it's gonna be sorry here. In the main, it's 7 grams and then a 9 gram redundant charge. And these charges
Okay.
are based off of our values from last year. We unfortunately couldn't get the testing, but we're planning on doing it this weekend. But the base sizes didn't change, so the number shouldn't really change.
Um, the whole it's not about the base size that should be changing the numbers of the grams needed. It is the volume size of the tube. So if you change like the length of the tube and the volume inside the tube, it will change it to be either smaller or bigger.
Yeah, the volume.
Most team,
Sorry,
go
the
ahead.
volume hasn't changed for the base.
Okay. Have you guys ever tried like maybe going like maybe like 6 grams to see if it would still separate?
Yeah, we're hoping to test 6 like the lower amounts in our testing, which is going to be in the next few days, hopefully. Yeah, the reason we have the larger amount is because we have 4 M5 shear pins, so they're fairly large, and we have those to hold back our drogue separation. So it can hold us back right now. I think it's at around 67 Gs. We were advised that around 50 could be expected, so we want to have that little bit of safety factor there.
Okay.
We are aware that it is
And just make okay. Just make sure to send me the deployment or the ground test deployment, like pictures of it deploying or a video
Sure,
to
sure.
the email or my email.
Yeah.
And then what is the shoulder length of the coupler sitting inside the tube? That should be one cal, which should be one body tube diameter.
This part's 6 inches right here,
Okay.
3 inches to the bolts.
And it looks like one side of the coupler will be permanently mounted inside the tube, correct?
It is removed, like we can remove it, the bolt, but we're gonna epoxy the one side bulkhead in.
Okay, so one side will be epoxied and the other side will be mechanical fastened in, or with shear bolts.
Yeah, so the bulkhead up here, the bulkhead that we're gonna have, this one's gonna be epoxied in, and then the actual tubing itself we'll be able to unscrew like this one. These will just be screwed in, and then for here is gonna be our shear pins.
Oh, okay, okay. And then what size shear pins are you guys using?
For the main, we're using 4 M5 shear pins, and then for the drogue is 3 M3 shear pins.
Okay. And anything going to be contained inside the coupler?
Don't think.
And there's a metal rod that we're gonna have in this upper piece here, but in I guess in here it's sort of the motor casing is like part of it.
Okay.
Like just the inner sort of structure. There's nothing like special in it. I guess besides
Yes.
the holder.
And your altimeters, where are those going to be located?
Those are all in the nose cone
The avionics bay.
in the avionics bay. Can you still hear us?
Move your screen. Where's function?
Able to continue.
Awesome, awesome. So the question I had for you guys was, how are you guys gonna wire your altimeters from the nose cone down to each ejection charge?
You want to explain?
So that'll be done with a wiring harness going down throughout all of the bays, all the way to the drogue. So we'll have little aviation connectors through each bulkhead. The aviation connectors you can kind of see there. So those are going to be pretty secure in each bulkhead. And then
Okay.
standard wires going down with bullet connectors to separate at the main or name, yeah.
So I know what those are. We do use stuff somewhere like that in the NASA sounding rocket programs and other projects that I work at with my industry. A lot of the other range safety teams don't particularly do rocketry for their full-time jobs too. They may not like that. Just be prepared to be questioned heavily more on those of the other safety reviewers have never used them before.
Okay, we'll come prepared with answers to their questions.
Yes. So everything that looks good there. And what are your altimeters that you guys are using?
We're using the AIM Extra 4 as our primary altimeter, and then the Blue Raven as our backup. And then we also have a redundant GPS system, which is the Featherweight GPS.
Okay. Awesome, awesome. Now let's talk recovery. What color are your parachutes?
So the drogue parachute is white and red, and the main parachute is white and yellow.
Okay. Awesome. There are two different colors. That's what we're looking for. And what are the sizes of the drogue and main?
So the drogue is 70 centimeters in diameter, while the main is 3 meters in diameter.
Okay. And what's the descent rate for both and the altitude for each of them, or altitude deployment for each of them?
So for the altitude, the drogue deploys at apogee, and for main, it deploys at the 457 meters, whatever that is in feet. 1500? Okay, I don't know. And yeah, so he just shows the maximum height for main just to give us as much time as we need for it to deploy. And then for the descent rates, I don't quite know the exact values at the top of my head. I believe the main is 6 meters per second, while the drogue is like 26 meters per second, something in that range.
Okay, I know by feet per second. Let me quickly look it up for the descent rate in meters per second.
They're in our last report.
Yeah, check the radius.
I go for descent rate?
Yeah.
27.5.
Yeah, so 27.5 meters per second for drogue.
And then parachute 6.4.
And then 6.4 meters per second for me. Yeah.
Okay. Um, excuse me. So the drogue was between, you said 26 meters per second?
Was it 20, 27.5 meters per second?
Okay, that is good then. And then what is the predicted apogee on your open rocket Bible?
That would be 3,164 meters, which is
You're just converting it to feet.
10,380 feet.
The 10,180 feet.
10,300.
80 feet.
10,300
Dang it.
and 80.
Sorry, I didn't do this. Yeah, sorry, I was a bit far away. It was 10,380 feet would be our predicted apogee.
10,380.
Yeah,
Okay.
and that was at worst case conditions. So I think it was like at 20 miles per hour. Because I think that's the maximum allowable launch at SAC from the range officer.
Correct.
Yeah.
So I'm glad to see that you guys did run the simulations for 5, 10, 15, 20 mile per hour winds since your rail velocity is under 100 feet per second. We just like to make sure people do that to make sure their rocket will be stable at all different mile per hours of wind. Since June is part of the spring/summer windy season of New Mexico. Last year we did see winds up past 20, so we did have to stop flights last year. And I think we called Wednesday early for the flight window, and that closed at 2.
Okay, I see.
So we had 2 hours of flying the first day last year. So be prepared if there is more weather delays, and try to be the first ones on the pad each day if it gets pushed back.
Okay, that's good to know.
Are you guys using any deployment parachute bags, dog bar, parachute blankets, shock cord protectors for your deployment?
Oh, I gotta talk over here.
I can open up.
Okay, so pretty much, yeah. So we're using Nomex blankets to protect the parachutes, and also the parachute bags are themselves with the Nomex. So at least that'll help protect the parachutes from the black powder. And what were your other questions? Sorry.
Just talking about the chute and parachute and shock cord protection. Which you're using the
Yeah, so pretty
parachute
much,
bag and the
yes.
Nomex.
So with the blanket, we're able to wrap up all the tethering there to protect it from the black powder.
Awesome. And what type of shock cord are you guys using?
So we're using two different types. We're using both Kevlar and nylon. We're using nylon just for one of the two cords for the drogue chute. The reason for that is to decrease the snatch force as much as possible. To reduce the G forces to hopefully prevent an early main deployment at apogee. And then the rest of them are just Kevlar. And also note that the nylon for the drogue will be attached to the opposite side of where the black powder is mounted, so to decrease the chances of being burnt.
Yes, awesome. And then what are the lengths of each shock cord?
Let's see. So for the drogue parachute, there's going to be a 2.2 yard Kevlar and a oh, I'll show you. When you want to. So pretty much you got a 2.2 Kevlar one and a 7 yard web nylon one, and the difference for the lengths are so that the rocket sections don't hit each other. And you can see them outlined there. Zach showing the actual parachute. Do you want to see the main now?
Yes, and then quick question. Just the braiding right now is just to make sure it's, or just to keep the shock cord nice and neat.
That's one of the reasons. The other reason, from Launch Canada, one of the advisors or judge told us to put them in this to help reduce that snatch force, because what happens is that knot becomes untied as it gets pulled. So it helps reduce the energy associated with that. And plus, yeah, like you said, to help organize it to decrease the chances of getting tangled up.
Okay, I've never seen that done before. So I really like that. So it must be a slip knot, most likely.
Sinnet knot, I believe it's what it's called. Yeah.
Okay.
Or chain stitch. It's also often referred to as a chain stitch. Chain stitch.
Okay.
All right.
Awesome. I like that.
Well, thank you.
And I bet you all the other range safety personnel, once they find out what that is, will like that method too.
Well, thanks.
And the connection points of the from the bulkhead to the shock cords, are you guys using swivel links, quick links, or what type of hard points are you guys using?
So we're using quick links to connect the bulkheads to the tethering. And then from the tethering to parachute connection, it's quick link, which connects the to tethering. And then in between that, a swivel link. And then after that, a quick link that attaches the parachute to the swivel link.
Okay, awesome. Glad to see there's no carabiners. A lot of teams have been wanting to use carabiners and elastic bands for shock cords.
Oh, wow.
Yeah. And then vent holes for in your nose cone for your altimeters.
Ventals?
Yes, because you want to make sure there is a pressure release inside the airframe of the nose cone for your altimeters to get a correct reading.
So we are going to have pressure holes in kind of the payload-ish base on that tubing there that you're looking at, but they won't be at the proper distance away. We will still get some pressure, but it won't be ideal, like nominal outside pressure. And so both the AIM Extra and the Blue Raven can deploy the drogue at apogee without that nominal pressure. And the main will then be going at like a slower velocity, so we can get that nominal pressure with those static ports.
Okay, other reviewers will have an issue with not having the pressure vent holes at the location of the altimeters.
The altimeters are inside the nose cone. So if they were going to be in the nose cone, that would be obviously some issues there. So that's why we're putting them further away from the nose cone in the payload bay, which
Oh, okay.
connected with that. You can see there's the holes on the bulkhead. The top of the bulkhead things that.
Yeah.
Yeah. So it will get air pressure through there very easily.
Okay, and then how many then, what size of vent holes are you guys having?
We haven't determined the size of them yet.
Okay. Since the vent holes are going to be further away from the altimeters, I would say at least have a minimum of 4.
Okay.
I usually do 5/16 um screw hole or drill holes. I believe it's 5/16. I have to look back. But you could definitely run the calculations for the size of body tube and how the distance of the locations from the vent hole to the altimeter is to get the proper sizing.
Okay, thank you.
When you do that, please also send me an email with the what size of hole you guys went with as well. And then let's go to the propulsion section. And this is also a fiberglass SRAD tube, correct?
It's carbon fiber.
Carbon fiber tube.
Carbon fiber cots tubing.
Carbon fiber cots, okay. And then the fin material is also fiberglass, carbon fiber,
Fiberglass. G10 fiberglass.
COTS or SRAD?
The SRAD. No, well, the actual material itself is COTS.
Okay.
Yeah.
And just shaped it yourselves with like a water jet or CNC machine? Okay. And fin attachment, through the wall, interior or exterior fillets,
I guess
or
we got
exterior mount.
this fillet here we did with epoxy, like a putty, and then these are epoxied on, but then there's alignment holes like dowels that go into the bulk. There's a centering ring in that side of here, and there's the like a roll pin, and it goes into the fiberglass pins and into the actual bulkheads as well. It's just for alignment.
Okay. So it's slightly through the wall mounting, but majority of it will be through exterior mounting.
Yes. Yeah.
Okay. Do you guys have you guys or from my point of view, it does not look like you guys did a tip to tip layer, or have you guys done a tip to tip
There is,
layer?
yeah, I forgot to mention that. There's tip to tip carbon fiber between the right along here. You can kind of see sort of where it bulges out a little bit here. And
Oh
yeah,
yes, I can see it now.
yeah,
Yes.
forgot to mention that, sorry.
Great to see that. Um, can I have someone on the team push down on the whole entire body as much force as they can to see if the fins will flex?
You can push that.
And can I get the view of it from the bottom side? Yeah, they're not moving at all. So your fin flutter should be good. What was your fin flutter velocity that you guys calculated?
We need the file. Yeah.
I know we did
Yeah.
flutter analysis,
It should be in technical.
We're just pulling that number up from the technical report.
Okay. And just to make sure, in the report two was the latest model on Open Rocket you guys had, correct? Or did you guys make any adjustments between them?
No, not really. It was mostly just
Oh,
it's just like small weights. But didn't it wasn't like anything, I guess like drastic in terms of like weight changes.
okay.
But like all positions and the thing in OR is pretty much the same as the last progress report.
Okay. Like your fin geometry didn't change from report two?
No,
No.
no.
Okay.
Yeah. In the appendix.
Should be in
As we wait for the fin flutter calculations,
it's in-
I didn't see a motor tube.
Oh, motor tube is right here.
all the way.
So that's actually the motor casing.
Oh, the motor tube, like this section.
Unless it's down there.
Um,
Okay.
Answer that.
So you build your reload in a phenolic tube that will go inside the motor casing, which is the aluminum tube. And most teams will then have a fiberglass or carbon fiber tube that will that the aluminum casing will slide into.
I think that was just done to the sending bulkheads, but oh, let me get Sean here. He has a better idea.
What's that?
Like some of the motor
Okay.
tubes that were how we're gonna slide in the motor casing.
Was your 2022 rocket similar to this
Did we have
design on the motor section?
No. There's no separate tubing. It's just the motor casing itself. And
Okay.
it's held
with
in
the centering
by
rings?
center rings.
So 5 center rings, okay. And how are you retaining your motor inside the aft section?
So the motor is retained by the top bulkhead here from falling out through this eye bolt and a thin thread side as well. So it screws into the top of the tube casing. And then on the bottom for the actual thrust transfer, we're transferring it through this aluminum bulkhead right here. Yeah.
Okay.
Into there.
Yes. Um, okay, is the eye bolt on the top of the motor section chemically um like chemically tightened onto the bulkhead or like several nuts keeping it from spinning off of the forward enclosure?
We can put Loctite on it.
What was that?
I said we could we can put Loctite on it, yes.
For extra bolts.
Okay, because we do have issues with the eye bolts unraveling themselves, and then the afton will just fall down without a parachute, since it will unscrew itself off the screw. I would suggest Loctiting it for sure into the forward screw mount. But if the aft thrust plate is also going to be securing it as well, you shouldn't have an issue with that either from falling out of the tube or the back end at least. But yeah, definitely for sure use Loctite.
Okay.
Um, yeah, most teams don't usually have a upper bulkhead through the eye bolt like that. So you probably want to just use like blue Loctite, not the red Loctite.
All right, sounds good. We'll write that down.
And I'm assuming your center rings are also 1/2 inch fiberglass.
Yep. Yeah,
Okay.
1/2 inch G10 fiberglass.
And how are they attached to the body tube?
They are screwed in. You can't see it anymore. But
Also, all of them are screwed
there
in.
are bolts in there, but when we did the tip to tip layup, so they're like permanently fastened to the airframe now.
Okay. Then how many screws did you use per centering ring?
6. There's
6.
two here, and then 2, and then another 2 on the other side.
Okay.
Yeah.
Excuse me. Then there were also 8 30-seconds
Yes.
screws.
Correct.
Okay.
Yeah.
Did you guys possibly also do like maybe epoxy fillets on each centering of the safety barrier?
On actual like centering itself, on the inside of the tubing, you mean?
Yes, around like the exterior on there where the centering will meet the interior diameter.
No, we didn't put any epoxy there.
Okay. Um, next time I would suggest you would, if you're not using a motor mount tube, since the centerings will be absorbing all the shock majority of the motor when it's burning.
Okay, we'll consider that for next year.
Yes. And then as we still wait for the fin flare calculations, unless you guys have that pulled up already, we can move on to another question. It looks like you're not using a boat tail and rail buttons. Where are your rail buttons locations going to be?
So our rail buttons, we're gonna have 2. It'll be so one will be in
Like
the
one's going to be right there.
and one will
Or-
be on the actual bulkhead itself. Yeah, for center.
Can you point me to the bottom location of or the bottom one location?
I think it's
That one right there? Okay. How far apart will the rail buttons be?
no, they'll be approximately 19 inches apart, 19 to 20 inches chunk.
19 inches?
Yeah.
Yes.
Are you still there? Hello?
Yes, I could, sounds like you guys are whispering.
Oh. Yes, 19 inches, 19 to 20 inches.
Okay, that's a good distance. Did you guys pull up your report with the fin flutter calculation?
You guys can't find it?
No.
Oh, you found it? Oh, we got it.
About half an inch per section. Take this apart and CPR. Watch if you want to show them this. Here.
So you guys,
Be the critical
what
speed.
was your flutter boundary speed that you guys calculated?
It was on our MATLAB code. I have to try and find it on here. Might take a while, so you might want to move on. Sorry. And come back.
Okay, so we'll hold on to that or come back to that. You guys pull that up on MATLAB. Um, what what style of rail button are you guys using?
Uh,
We can show you.
we don't know the name of them off the top of our head, but we have them here.
And are they meant for 1515 rails?
Yeah, unless it's changed, then yes.
I think so. These are the same type that we've used.
And
pre-
SAC 2020.
Yeah, SAC 2022.
Okay, before you install them, make sure they're meant for a 1515 rail. That is all that we use at Spaceport America Cup. We might have another Canadian team that will bring their own rail, which is a metric rail button, just in case that is a metric button. And they are usually kind enough to allow other teams to use their metric rail if they messed up and not getting 1515 rail buttons.
All right.
And then what motor are you guys using?
We're using the M1800.
And
Yep.
like, did you and
And you guys already made that order to make sure you guys could get it for competition this year with CTI's production issues.
Yeah, we confirmed with Animal Motor Works that they already had the motor in stock, so they didn't have to put it in the order with Cesaroni.
Okay, awesome. And you guys are not a multi-stage.
Nope, not
It's
stage.
been ordered. Have you guys built a motor before?
yes,
Yeah. We have
Okay.
experience with it.
the delegates who are attending won't have experience building a motor, right? Just Adria, you're not coming.
Yeah, but
I
I have
explain that to them.
yeah, I have the whole procedure. We also have like a video of like doing a step-by-step assembly. So I won't be there, but I'll be walking some of the delegates through how to go, yeah, building the motor and all the, I guess, essentials for it.
Okay. And I'm pretty sure Garrett could also help you guys if you have any questions with building the motor, since he is your flyer record.
Yep.
I know Animal Motorworks, and I think the other motor vendor that we're also teamed up with this year will be doing motor building workshops at their hotel's conference center.
Okay.
So you could ask the question on Hero X on more information regarding that,
Okay.
which I don't have all that information.
Okay.
Yeah.
That's good. Yeah, because I know during SAC 2022, Robert DeHate was actually like walking us through it, luckily, but we'll message him and see. So, well,
Okay.
Connor, I'm also a motor vendor, so I've made hundreds of these things. So
Oh, okay. So
yeah, all right.
you know how to properly build a motor and help
Yeah.
them
Yeah.
if they have any questions.
Yeah, I do.
And then also for your aft end of the rockets, you'll need to make sure, actually, I believe in the D tag this year in section 8.7, let me pull that up. Every year, team markings on the rocket have or keep changing. Last year, we required the team number and frequency on the bottom end of the rockets. I think this year they're requiring every part of the rocket to have the team name, number, and GPS tracking frequency. So every body or exterior piece of the rocket, so nose cone, the upper body tube, and the aft section should have the team name, team number, and GPS frequency
Okay.
or frequencies
Sorry, did you
that you
want
guys are given.
frequencies for all of our flight computers or just the GPS specific ones?
Whatever frequencies that what is it called? What's the company? Greek name. When you fill out the frequency form for the company that we work with to track the rockets and flights, write down all the frequencies that they give you.
Okay, sounds good.
I forgot the company's name, but you'll be filling out the form at the convention center for your given frequencies for your flight and your rocket.
Okay.
And also in the D tag in Appendix F, it'll show you I believe what is all needed and for proper sizing as well.
Is it Da Vinci Maker Labs?
Yes, Da Vinci.
Yes.
Da Vinci will be giving you guys your frequencies for flight. So make sure to look up D tag 8.7 and Appendix F for your markings.
Okay, sounds good.
Have you guys pulled up the MATLAB code for the?
Page here, so
I like that. 'Cause I know.
I think we
Oh, I think they're
found the calculations. Yeah.
okay.
Okay.
Sorry for the wait. I think it may be this one. Critical flutter speed 788 feet per second.
Okay.
Okay.
That's a boundary speed. So half of that should be your max safe speed to fly.
Okay.
But I ran my own calculations. I found your velocity for fin flutter to be 6,091 feet per second.
Yeah,
Your
that's
max safe speed should be 3,046 feet per second. And after opening up and running simulations on your open rocket file, your simulated max velocity should be 869 feet per second. But you also said you changed your open rockets file since report 2 and added some weight. So I don't have the updated calculations for that.
I think the weight should be, I think, 31.7 kilograms.
On can you go to plot?
Okay.
No, an open rocket. Can you
Oh.
there you go.
in the upper right side where it's HUD simulations? Oh, I just need altitude and velocity.
Okay.
Zoom in where max velocity is. At the point of max velocity, go up to altitude, please.
31.
So like no, the point of max velocity. So the highest point X value there. What's the Y value for the altitude now at the same X point of 6 point 11.
About 632 meters.
632.12 meters. Oh, Lord.
Oh boy.
Let me convert that.
Yeah.
All right, that's AGL, right, guys? Because you don't have the 4,000 foot altitude built into your simulation, or do you?
Yeah, that's HGL.
That's why I brought it.
Yeah, what's your simulation parameters for your launch field?
Yeah, I handed to it, Mark. Like, oh, this is
Simulation. Yeah,
I mean, sorry, I just sent this question.
I don't know where this house is. Like you're polishing this all. Yeah. So that's all. Yeah.
4596 seems a little high.
Like I made like tons and tons, right? Just testing, and I only.
I think that, yeah, that's the one we got yeah, but I think the VLA.
It's like, yeah, kind of work a little bit, and you get work too much, and the camera starts on, so like.
Actually, altitude at Spaceport should be a little bit over 5,000 feet. So that should be a roughly good. And then rail length should be 17 feet.
Yep, rail lane. Yeah, I got you. Yeah. Oh, yeah.
Yeah, that works.
Yeah.
They want to simulate and plot to make sure everything's the same.
Yeah. So here, about 249 meters. And then the corresponding altitude of that about 652. 636.
Make sure it's going to be at the same X point or X axis of the max velocity for altitude.
Yeah, about
So you actually zoom in a little bit more, you could get a better
yeah.
Oh yeah, that's about right.
Here, 259.
so 788.43 meters.
Yep.
That is 2,586.71 feet. Yeah, so your velocity of your fin, your flutter boundary speed velocity should be 6,049 feet per second. With a safety factor of 50%, the max safe speed should be 3,024 feet per second. And if I remember correctly, what is your simulated max velocity now?
Simulated max velocity would be about 3,135, which is that speed.
Like max velocity was what?
Oh, max velocity would be about 267 meters per second.
Oh.
267.
All right.
800.
No, I run what 900.
That's 875 or pretty much 876 meters per second. Ooh, I have it should be at 869. You guys are past the 50% safety factor by 7 feet per second. Well, you did add weight to your rocket. Stop the recording.
That's not recording.